Okay, we have another volume by cross-section problem here, so let me read that. So let R be the region of the solid, bound by the graph y equals x squared and y equals 1 minus x squared. For this solid, the cross-sections perpendicular to the x-axis are squares. Write, but do not evaluate, an integral expression for the volume. To help us get an idea of this problem, let's go ahead and graph this, the base at least of it, and we'll see what's going on. So we have our y-axis right here, and then we have our x-axis. And then let me graph our two functions. So I'm going to choose, let's let the base of that one, or x squared, be in blue. So that's going to be this one right here. And just getting a ballpark picture of what this looks like. And then I'm going to go ahead and graph the other function as well. And that's 1 minus x squared. So I'm going to just approximate, let's say 1's way up there. And that function is going to look like this. Okay, so that's the bottom of our region. Now coming out from that base is going to be, if we take the cross-section of those perpendicular to x-axis, those are going to be squares. So maybe I'll just draw one square coming out of there, and I'll change that back to black so we get an idea. So if I say let's let this right here be our base, and coming out of that will be a square. Okay, so there's one right there. I'll make that have a little bit of thickness. And maybe I'll do one on the other side just so we got a really small one. We'll get the idea of what's going on. Okay. So if we draw a whole bunch of those, we want to find the volume of that solid. And what will happen is those will eventually fill in. Now to do that, we're going to think about this, we're going to first find the volume, maybe just of one of these cross sections. So let's look at maybe this one right here. And to find that, that's a rectangular prism, so it's going to be the area of the base times the height. So we got to think about how we're going to do that. Now the base, those are both squares. So we would be able to find the area of the base from geometry, that is side squared. And then the height is just the distance between the two bases. So we're going to want that to be dx, infinitely small. Okay, so we have the area of the base of each square, that's side squared. The problem with that is we want to put that in terms of x because how big each square is depends on x. So first let's think about what s is. So the s, that's going to be right there. That's going to be the distance really from that green function to the blue function. So if we were to say that's the side right there, that's going to be 1 minus x squared. Okay. That's the top function, and then we're going to subtract the bottom function, that blue function, and that's going to be x squared. And so if we were to simplify that, that would be 1 minus 2x squared. Okay, so that's the side. Now what we're going to do is to integrate, or let me back up, to find the base as a function of s, we're just going to plug that in over here. So we're going to take this whole thing and plug that in. So really, the area of the base, if we're going to put that as a function of x, that's going to be 1 minus 2x squared. That's the side, and then we square that because that problem right here, so we square this and we square that right there. Okay. Also from calculus, we learned to take the volume. That's just one slice of this, but we want to add those all up. So to find the volume by cross-section, we're going to take, I used b of x, so I'll use that here. And we're going to add all those up. So from here, all we have to do is substitute. So we have the integral of 1 minus 2x squared and dx. Okay, and the one last thing we have to figure out now is we got to figure out where that goes. That's from the upper and lower limits that we're going to integrate. Well, that's these points of intersection over here. So we got to figure out what those point of intersections are. To figure out the point of intersections, what we're going to need to do is, one way of doing that is just by setting the functions equal to each other. Okay, so let's do that. I'll keep the colors the same. So to find those, we would do x squared equals, so that's one function, and then we'll do the other function, and that is 1 minus x squared. Let me clean that up a little bit. When you set those two equal to each other, then you would just solve for x, and we'll kind of run it out of space here, so we'll do it real quickly. So we add x over, and so we'll get 2x squared equals 1. And let me move up just a little bit. And then what we need is solve for x. So we're going to divide by 2 and then take the square root. So it's plus or minus 1 over the square root of 2. And those will be our two upper and lower limits. So let me write that up there. So 1 over root 2. In calculus, we don't need to rationalize. We can just leave it like that. And there we go. That's how we find the volume. Let me make that a little bit smaller now. And there we go. That's finding the volume by cross sections when each slice is a square.